Hey guys, this lesson is going to be on organic molecules, just a brief introduction, and then we'll go into separate videos for the different types of organic molecules, which are carbohydrates, lipids, proteins, and nucleic acids. First of all, organic compounds are all made up of carbon. I know a lot of you, when you hear organic, you think about what you see on TV and what you get from the grocery store, but really anything you eat that contains carbon is considered to be organic. So what they really mean on TV is that they have not added pesticides or steroids or things like that to your food. Whereas sometimes the food that you get from the grocery store, if it doesn't say organic, may be something that has been genetically modified. But overall, what it means to be organic is that it contains carbon. Okay, so for example, I'm going to write one on my board that I have here. Okay, so this is glucose. I think you guys are all familiar with it. It is a sugar. We eat it, right? So glucose is considered to be organic. It has the carbon. You can see here it has the carbon, and it's usually associated with hydrogen and oxygen, and so it's considered to be organic. What about this one? What about this one? Okay, this is carbon dioxide. We get rid of this whenever we exhale. Okay, so carbon dioxide, it's a gas. We don't really eat that or take it in, so it is not considered to be organic. If it's something like this, it's considered to be inorganic. Most of your chemistry classes are in organic chemistry. Another example that is really important for life is water. Okay, really, really important, but it's not organic. It's not organic because it does not contain carbon. Okay, so this is also inorganic. Even though it's really, really important for us, most things in our body cannot happen without water. It's not considered to be organic. Okay, this first one, definitely organic, sugar. Okay, this one and this one are inorganic. Even though this one has carbon, it's a gas, it's not considered to be organic. Okay, now carbon, we've talked about already, has 4 valence electrons, which means it can bond with lots of different things, which gives us the ability to have all those different organic molecules like carbohydrates, lipids, proteins, nucleic acids. And what makes them unique is that they have functional groups. Okay, and as we go through all the different types of organic molecules, we'll look at their functional groups. The functional group can change a molecule by a lot. So for example, we talked about methane, which is CH4. So it has a carbon with 4 hydrogens attached to it. You guys remember this from class. Okay, so that's methane. If I take off one of those hydrogens and replace it with a hydroxide ion, or sorry, not ion, but functional group here, now it changes from methane to methanol. Okay, so this OH at the end makes it an alcohol. So we've just changed it from a gas to a liquid. Okay, so these functional groups give it properties that allow it to be the different types of organic molecules that we're going to talk about. So the functional groups kind of determine what the properties of that molecule is going to be. Okay. Now, organic molecules are really large molecules, so we call them macromolecules. Okay, they're macromolecules. Macro means big. But it cannot be just this one big structure, otherwise it would collapse. Kind of like us, we are huge, right? But we're made up of a whole bunch of small parts. Well, the small parts that make up the organic molecules, or the macromolecules, are monomers. Mono, if you see here, means one. Okay, well, one block plus another block plus another will help us get to the point where we have these large macromolecules. When we start building these monomers together, putting them together, we get polymers. And what does poly mean? Poly means many. So you have a whole bunch of monomers all stuck together to make a polymer. Now these polymers are what make up our macromolecules. Okay, like starch, plastics, typical things in your everyday world that are large are made up of smaller molecules. Okay, so monomers build polymers, and these polymers are called macromolecules. Okay, again, macro means large. Okay, macromolecules are the largest polymers, and there are 4 types: carbohydrates, lipids, proteins, nucleic acids. Okay, if I say, what are the 4 types of organic molecules? You hopefully will say carbohydrates, lipids, proteins, nucleic acids. If I ask you what are the 4 macromolecules, hopefully you'll say carbohydrates, lipids, proteins, nucleic acids. If I ask you what the 4 polymers are, you hopefully will say carbohydrates, lipids, proteins, nucleic acids. So those 3 words, organic, macromolecule, and polymer, all kind of encompass the same 4 examples: carbohydrates, lipids, proteins, nucleic acids. Now, as we go through future videos, I'm going to show you and talk about the monomers that build up those polymers. Okay, so you're going to have to be able to go back and forth between the monomers that make the polymers and what happens when those polymers break down. We end up with monomers. Okay, so this is just a very brief introduction to organic molecules. Overall importance, knowing that organic molecules are made up of carbon and that they have building blocks. Monomers make up polymers. And the 4 major types of polymers, which we also call macromolecules, which we also call organic molecules, are carbohydrates, lipids, proteins, and nucleic acids. Okay, stay tuned for future videos.